So the lymphatic and immune systems are commonly grouped together because they share a lot of the same functions and a lot of the same structures and organs that function in both capacities. The lymphatic system in itself is not probably something that you commonly hear about. It's a very obscure system, I would say, because its functions are just to maintain fluid balance in your body. So all of your interstitial fluid, all of the free-floating fluid that's not considered blood, this fluid that's between your cells, it's maintaining that so that you don't have swelling that occurs. It's also going to house your immune defenses of your body, which is why it's grouped together with the immune system. And it also regulates absorption of lipids from digested food. It does so by chyme, and that's something that's released into the digestive system. So the lymphoid tissues, things that are considered lymphatic in function, there's a lot of lymph vessels throughout your body that take excess fluid out of your blood from the plasma to circulate it throughout your body. You have lymph nodes, and those are storage centers for lymph. Sometimes those can get infected and they can become enlarged, and we'll talk more about that. Your tonsils and adenoids are also lymphoid tissues. They function in an immune capacity as well. The thymus that we've talked about before in endocrine, its main function is in the immune system and lymphatic system. The thoracic duct is one of your main lymph vessels. The spleen is majorly lymphoid in function. Peyer's patches are these little aggregates of lymph tissue in your small intestine, specifically in your ileum. Your appendix is also lymphatic and part of your immune system and function, and it's found hanging off of your cecum in your large intestine. And also your bone marrow is part of your lymphatic and immune system, as it makes a lot of your immune cells. And without it, you have a very depleted immune system. So lymph is the fluid itself that circulates throughout your body. It's a clear fluid. It's found in your lymphatic vessels. You can see from this very complex diagram, the red parts of the vessels are your arteries, the blue parts are your veins, and the part where they meet is the capillaries. So there's lymphatic capillaries that attach to your regular capillaries, and they collect any additional fluid that's floating around in your blood plasma, and they circulate it throughout your body to maintain your fluid levels. If for some reason your lymphatic vessels are not functioning properly, say they were damaged because you have a sprain or a strain, you may have edema or swelling in places where you normally would not. Lymph nodes are linked together by lymph vessels all throughout the body. You actually have about 500 to 600, which may be more than you previously thought you had. They're located pretty much everywhere, and depending on which ones are swollen tells you where the problem is. So if you have lymph nodes in your pelvis, those usually are an indication of some abdominal or pelvic infection. You can have ones in your armpit, and sometimes that can be a sign of a breast condition or an infection somewhere in your chest. Normally, if you have cold or flu-like symptoms, you will have swollen lymph nodes in your neck, under your jaw. They're going to defend the body from pathogens, and they're also a site of maturation of some of your lymphocytes, your white blood cells. So those specific white blood cells. So if you have swollen lymph nodes, that's because they were defending your body from pathogens, but they were kind of fatigued. So they were kind of overrun with the pathogen, and they might have a little bit of an infection themselves. So generally, your white blood cells will come in and help relieve them of that infection. Or if you're taking an antibiotic because it's a bacterial infection, the antibiotic will help to cure them of that. So we'll start to get into the actual sites of the lymph the lymphatic/immune system. So the tonsil, you might not know that you have as many tonsils as you do, because you normally think of tonsils as the two little things in the back of your throat that get inflamed when you have tonsillitis or a sore throat. You actually have 3 different pairs of tonsils. You have palatine tonsils that sit on the sides. Those are the ones that you see when something's wrong. You have pharyngeal tonsils, which are way in the back of your mouth. You don't commonly see those. And you have lingual tonsils that sit behind the root of the tongue, so you'll never see those. They form this protective ring under your mucous membranes in your mouth and in the back of your throat. If you have tonsillitis, it's an infection or an inflammation of these tonsils, usually the palatine tonsils. And a tonsillectomy would normally remove the tonsils if they're chronically inflamed. And it's usually a removal of those palatine tonsils. Your Peyer's patches are these aggregated or clusters of lymph tissue in your ileum or a portion of your small intestine. They're going to provide immune surveillance, so they kind of let your body know what's going on where you have the largest amount of bacteria in your small intestine and your intestines in general. So they provide a sort of surveillance capability of letting your body know if there are foreign invaders. So your thymus, we've talked about in the past. We've said that it gradually atrophies with age, but it serves as a final site of your lymphocyte development before birth. And it also secretes a hormone called thymosin that matures T lymphocytes that we're going to talk more about soon. But you can remember that it's T lymphocytes because thymus starts with T. And remember that the thymus is in your mediastinum, just anterior to your heart. Not to be confused with the thyroid, which sits in the anterior part of your neck and functions more so as an endocrine organ. Your spleen sits just posterior to your stomach, and it is known as your red blood cell graveyard because that's where your red blood cells go to be phagocytized once they are dead. It also serves a little bit of function in hematopoiesis in making those red blood cells. It's not a vital organ. It also atrophies with age. And we know it's not a vital organ because when it enlarges with things like infectious disease, especially things like infectious mononucleosis, if you've ever had mono, and if you've been an athlete, especially with contact sports like football, they say not to play contact sports if you have mono because your spleen can be enlarged, and if you get tackled or hit in any capacity, the spleen can actually rupture and you could die from the amount of blood that you lose internally due to this splenic rupture. But generally, if they get to it in time, they're able to remove the spleen and you can live without it. It's not a vital organ. So the immune system itself, we've talked a little bit about antigens and the function that they serve in red blood cells. Antigens are pretty much everywhere in our body, serving as markers that determine what's us and what's not us. So you have identifiable antigens on everything in your body that tells your body that this is part of me. If a foreign invader comes into your body, a bacteria or a microbe that doesn't have that marker that shows, oh, I'm part of this body, then your body knows to attack it. So the immune system, we'll talk more about antigens and their functions coming soon. But for now, the immune system is split into innate or non-specific immunity and adaptive or specific immunity. In innate immunity, it's a general defense against non-self particles. So it sees that non-self thing, whatever it may be, a bacteria, a virus, and it's a general defense mechanism against that. We'll talk more about details in the next slide. Adaptive or specific immunity recognizes specific threatening agents. Say that your body has seen this virus or bacteria before. It knows exactly how to fight it off because it has antibodies that it has made for specific antigens. So it sees that marker of something that's non-self and say it's for influenza. It's part of the influenza virus, and it has you have specific antibodies that fight that influenza virus, and those recognize that it's that, and they know exactly how to fight it off. So these T and B lymphocytes play a major role in that. Let's talk first about innate immunity, which is that non-specific immunity. It has your first and second line of defense. So your first line of defense is your skin. It protects you from any foreign invaders that might be on any of the surfaces that you touch on a normal day-to-day basis. As long as you don't have a cut in your skin, that first line of defense is very protective from a lot of different pathogens you may encounter on a day-to-day basis. Your second line of defense is your inflammatory response. So a lot of people think that this is a bad thing when they start to get a fever, when they start to get pain or edema or swelling and redness. But it's actually a good thing. It shows that your body is trying to fight this thing off before sending out its heavy hitters. So the reason why you get a fever when you get things like the flu is because that your body knows that if it heats your body up to inhospitable temperatures to these viruses and bacteria, that they'll have a really hard time replicating. So the whole purpose of getting a fever is that your body is trying to stop this virus or bacteria from continuing in your body. So it's kind of cool. The pain and the edema and the redness is there, and the edema is there as a sign that the red and white blood cells are in the area fighting this infection. And the pain is so that you're aware of it as well. The chemotaxis is the movement of the white blood cells to the area where there's this foreign invader. So chemo means chemical, taxis, like taxi, means to move. So it's these white blood cells moving toward a chemical. So they literally sense a chemical change in your body because there's these foreign invaders or microbes. And they go toward the area and they attack it. A lot of the times they do phagocytosis, where they engulf, like Pac-Man style, and attack whatever foreign invader is there by just engulfing it. You also have natural killer cells that are part of this innate immunity response, your secondary line of defense. They're non-specific lymphocytes, which is why they're considered part of this category. And they kill via chemicals, so they don't phagocytize things. So adaptive immunity is specific immunity, and it includes your third line of defense, where your heavy hitters lie. So your B and T lymphocytes. Your B cells, or your B lymphocytes, they're going to make antibodies. So they're going to remember, by memory B cells, when you get a certain disease. So say like you get say you get a specific virus like the flu. When you get the flu, your memory B cells remember exactly what that flu looked like. And your B cells make antibodies so that if it ever comes in contact with that strain of flu again, then your body knows exactly how to fight it off. When your body fights something with antibodies, it's called antibody-mediated immunity. And another word for antibodies is immunoglobulins. T cells are also part of your adaptive immunity. T cells or T lymphocytes, they're going to attack cells directly. So that's called cellular immunity. So you have different types of immunity as well. You have active and passive immunity. In active and passive immunity, you have natural and artificial or acquired forms as well. So first let's talk about active immunity. Natural active immunity is when you get an infection, and once you get the infection, your B cells make these antibodies and remember, due to these memory B cells, exactly how to fight off that the next time it comes around. So natural active immunity is when you have had it before and your body made antibodies against it. That's why a lot of people had these chicken pox parties where they had all their kids get the chicken pox on purpose in order for them to make their own antibodies. There's also an artificial active immunity or acquired active immunity, which is a vaccination. It would be the same process as getting the infection and making the antibodies, just without getting the infection with all the symptoms. So you receive a vaccination, usually of an inactive form of the virus, and you make antibodies against it so that if you ever come in contact with it, you either don't get infected by it or you have a much less severe reaction to it. A lot of people are against vaccinations because of their additives, but you can also get vaccinations that don't include those additives. You just have to ask your doctor for them. Passive immunity, there's the natural passive immunity, and that's through maternal antibodies. So there are maternal antibodies that are passed via the placenta during pregnancy. The baby automatically gets a little bit of its mom's immune system just through the placenta. It's also passed on naturally through breast milk, through breastfeeding, where a lot of the antibodies and a lot of protective mechanisms are passed through that. So that's why they say it's really, really important to breastfeed if at all possible, just for that extra little dose of immune system for the baby. Artificial or acquired passive immunity is through the transfusion of monoclonal antibodies. So they do this sometimes when there's a really severe infection that's going around. Something like Ebola, when that was first going around, there was somebody that had that disease and then got over it by themselves, which would mean that their body had created antibodies towards it. They might take his blood and give it to somebody who has Ebola so that they're able to fight off that disease with his antibodies. So that's it for lymphatic and immune systems. Let me know if you have any questions relating to this. Make sure you read the chapters on it for this week's reading assignment.